The first one is this one. So let me zoom in a little bit. Okay, good. So the question 9, right? Okay. Question 9, can I take a look at your work? Okay. So you can use the graphical software or app to see whether you have a good shape or not, right?
Yeah.
So in fact, that's one way for you to like this is our assignment. So you can easily use technology to check whenever you have graph question, whatever it is, draw, sketch, whatever. Okay. So actually looking at your this, did you use your this French curve?
Nope.
No. Okay, good. So when you have your French curve and you don't use it, so what you use the French curve for then?
Nothing.
Collect dust?
Yeah, collect dust.
Okay. Okay, so I just want to demo to you once. Okay. So have you ever touched your French curve before?
Yes.
Okay. You took it? Huh? Yes. Okay. So can you get a pencil out? Can you get a pencil out?
Yeah. Pencil out.
Mm.
Need any ruler or anything?
Not at the moment. Just pencil and a ruler.
Yeah.
So, okay. You have. I think you have 3 sets. 3 sets. One set of three of them, right?
Okay.
So, if you look at this one, okay, you can try to use this see if you can link the 3 points up. Okay. So, or you can even use this to you can adjust. Okay, you can adjust. Okay. So looks like so somehow you need to adjust. Okay, so okay, good. So looks like this is the one I should use to link 1, 2, 3, 4 up, right? So just adjust it to fit yourself. So I think the first part is you try to link this 3 point up first. Okay, so you link this 3 point up first, then you stop here, and you continue to. Can you see? It will give you a very good curve.
Yeah.
Okay, and then after that you just.
It's kind of like a ruler for curves.
Yes, exactly.
How about those?
So
like those?
that's how you get a good curve without compromising on the accuracy. Yes.
How about like these points?
Yeah. You can use any shape.
Oh,
Okay. So I have demo to you. Especially, generally it's very hard to link these 3 up. I mean the bottom here, right?
Yeah.
So
it's
actually it's
weird.
yeah. So you can actually use of this. Okay. Or you can even use this. Okay. So that is how you get a very good curve out. Then over here, something to take note is you need to use the stated scale.
Yeah.
2 cm to 1 unit for the 0 to 6. So basically I should see 0 to 6, not any 0 to 6. So anything beyond 6, you don't have to draw it. Okay? Then I should see 0 to 22. Yeah, 22. Yeah. So always give yourself a little bit of allowance so that in any event they want to add on something, you still have the allowance space. Then use your graph to solve this. How do you solve this? Like equal to 12.
That's the one I don't know.
So okay, so this is quite mathematics.
Actually,
I think you should know because this is your y.
Yeah.
This is your y, okay, which is 2x plus 18 over x squared. Okay, and then now they say equals to 12. So this is your y equals to 2x plus 18 over x squared. So now they say instead of equal to y, so that means you replace your y with 12.
Wait, where are you going to 12?
Here. I'm doing C.
Oh.
Okay. So I equate it to 12. So that means initially is 2x plus 18 over x squared equals to y. So now I force my y to be 12.
Yeah.
So what does that mean?
And quadratic equation.
No. What do you mean? What do I mean by that? Like let's say start with y equals to this, then now I force my y equals to 12. So what does this mean graphically?
Find x.
Find x, right? Given
y
equals to 12. So how do you solve it graphically?
Why? I think.
We are talking about graphically now.
Yeah.
We're not talking about solving it
Mathematically.
mathematically. So y equals to 12. Go.
Oh, you just draw this
draw a straight
horizontal
line.
line, then find the intersection.
Correct.
Oh.
Okay. You call these intersection points.
Yeah.
Okay, good. So you draw the y equals to 12 now.
Then there's 2 intersection points.
Yeah. So yes. So you label y equal to 12 over there. Okay. So the 2 intersection points. Then you read it from the graph. So over here you would need to use dotted line. Then you label the point on the graph. This is tested, right?
No, but it's good. Doesn't matter anyway.
Okay.
It's good. Anyway, in end of year it's gonna come in like after W3 it's gonna come in like 3 weeks. Okay.
Okay, so
This. I like this ruler. It's nice.
Yeah.
My ruler is really small.
So you like the color as well? Many years of usage.
Yeah, I can say that, but not particularly of the color.
Okay, good. So that's how you get the they say what? Use the graph to solve. So this is how you solve this mathematically.
Sorry,
Graphically
graphically.
here. Over here is graphically. So let's say if they say, hey, I don't want to have 12. Let's say I say 12 plus x. So how you do it? Let's say not
Put
12,
x
but 12
over.
plus 12 plus x. So in a way, right, now they force your y to be x plus 12. I just rearrange it.
Yeah.
So what you need to do is you need to draw. Okay, just now we drew the y equals to 12, right? So now I change to x plus 12. So you just drew the y equals to x plus 12 in this graph. So how do you draw the y equals to x plus 12? How do you draw anything? How do you draw anything?
By finding
Give yourself a table of
values.
y equals to x plus 12.
Yeah.
Then you just get maybe 2 points or 3 points, then you can draw it.
Or then find the intersection
Okay,
points.
so let me demo this to using the GeoGebra. Okay, so you don't have to go through this, but I want you to go through the y equals to 12 one. So what is the formula?
I can tell you y equals to
Yeah, you need to tell me yes. Y equal
2x
2x
plus 18 over x squared.
18 over
X squared.
x squared.
Correct.
Okay, good. So it looks like this, but because yours is
Just
there's a range, right?
Yeah, it's
So there's a range, so you don't see this part, but it's
Yeah.
okay. So you focus on this part, okay? So now they ask
y
equal this to 12. So what you do is you insert y equals to 12 with. Can you see?
Yeah.
So you can actually use this graphical app to check whether your this is accurate enough, right? So you just point to it. So you will see that your x should be 1.4.
Correct.
Yep.
Yeah.
So this one another point. So you should get hold on.
Like 5.7 or 8.
So let me just zoom in. How do I get this point? Okay, let me just note down this point. Okay, good. So let me go back to this. Point A is 5.7. Yeah.
Yeah. 5.7.
Yeah. Good. Okay. Good. So if they ask you to get the y equals to x plus 12, so they force it to be x plus 12 now instead of 12. So you just insert another. That means insert. Okay. When I use the app, so I can easily insert. For you, you just
Table of values.
yeah, tables of value that fits this y equals to x plus 12. Then you get it. Okay, so it's a straight line. So if you look at this, so it cuts the so yeah,
Cuts it.
that point and that point. Okay.
So you had to
Yeah.
extend
Good.
it.
So yes. So this you don't have to do this, but because this the last part y equals to x plus 12 is the question I just
You just make up.
yep,
Yeah.
yep, I didn't plan it, so just think of it offhand. All right. Then what's the next question? they say what? By drawing a tangent, find the gradient of the graph at x equals to 1.5. So basically, you just get where's x equal to 1.5?
Here.
Nali. Okay, so go there. So where's the point?
Yeah.
So mark the 1.5. Okay, 1.5. Mark the point. So you need to draw a tangent, which is this. You know what's a tangent, right?
Yeah, cuts.
Tangent means cuts at one point only.
Yeah.
So you somehow that's the reason why your curve need to be accurate. If not, it's going to cut more than one point. That's why you need to use this French curve. Okay, so you just draw a straight line that cuts the curve at one point. The x equal to 1.5. So longer the better. Okay, so once you get long, okay, never mind. Next time try to make full use of the spacing. Okay, but I think now it's good. So you have this tangent. You should write tangent. So you can write tangent at x equal to 1.5, so that they know that this is the tangent at x equal to 1.5. So they ask you to find the gradient of this tangent, right? How do you find the gradient of this line? So just pick 2 points.
Yeah.
Of course, you don't go and pick 2 very hard points.
Yeah.
You put easy points. Okay.
Then after that
You use the y equals to gradient equals to.
Yeah, y2 minus y1
Yes.
over x minus.
Correct. That's how you solve this 2 marks.
Okay.
Okay. So that's the reason why I want you to draw a good curve instead of freehand. Because when you use freehand, right, things are going to be a lot off sometimes. So if your this curve is way off, then
Wrong.
then your this C you will be a bit off, then D is a bit off. So when you have a lot of things off, they add up, then you lose maybe 3 marks out of this, maybe 10. You can't afford to lose a grade because of your freehand drawings, right?
Yeah.
Okay, next one. Question 5. So this other one.
That's a different.
Yeah, this is a cubic one. Okay, so this is a cubic one. Okay, so the cubic one, did you check against the GeoGebra app?
I didn't even draw.
Oh, you don't know how to do it?
Yeah. The cubic one.
No,
I think
why?
just make the
I thought you have the P, you need to find out what's the P and then that's it. Just plot the points.
No, I was talking about
Yeah?
the C.
A, you get the P already?
P
You even have a...
here.
Okay, so once you get P equals to what?
Negative 18.
Negative 18. So basically you just plot all these points out.
Okay. That's
So, so why I give you this cubic? Because if quadratic can come out, cubic can come out. Okay? So basically you get all the points. So you have all this.
Okay.
Okay? So once you have all this, right, then the more you need to use this. Okay? Good. So let me
Sometimes
just
like
yeah?
the y or the x value are really like big numbers. It's really hard to draw, like to plan out and draw.
No, they give you the scale, right?
Yeah, they give me the scale, but still, sometimes the scale is like a large scale.
No, okay, good. Can you see?
Yeah, I can
Yeah.
see.
Okay. Okay. So during our practice, right, I think you can kind of like use the GeoGebra app to help you out to plan your space. You
Okay.
understand my point?
Yeah.
So because I know without okay, I mean you can actually see the graph, then you know that how it looks like, then you can plan your space, right? So in a way, can you click it? Okay, I just get this out. So go to GeoGebra app. Can you note down the equation first?
Okay. The equation.
Y equals
To x.
oh, okay, good. Never mind. So I just get this. So I'm going to clear everything. So y equal x cubed and then minus 3x square plus 2. Okay, this is how it's going to look like. Okay, so we just focus on just here. Okay, so in a way, right, you don't have to do it. You go back and do it. Okay, so I'm just teaching you the approach. You are here to learn the approach. All the minor small details, right? Then we have to sort it out.
Separate.
Yeah, separate. So over here, you just plot the point. So you will start to see, hey, your point is up, down, then up again. Okay, so cubic usually is up, down, up again. For quadratic, it's just either smile or frown.
Yeah.
For cubic, it's more
More complicated.
more complicated. Okay, so once you get this right, okay, so let's assume that you can get this. So what is the next question?
Next question.
Use your graph to find the equation equal to -2. How do you do this? Find a solution to the equation. How do you do this? Can you write down the C, part C? Just write it down behind. Yeah. Write down the question.
What?
Write down the question.
Yeah. X. Is it x cubed?
Yeah, x cubed.
Minus 3x squared equals -2. Okay.
They ask you to find the solutions, right? Okay, so you have drawn this out already.
Oh, so just put it back to.
Correct.
Y
You put it back. Put it back
to
is the same
format.
thing, right? That format. Then you look at which one, where you look at on the graph to find the solutions there.
Okay, then so this one then equal to 0.
Correct. So basically, you look at this point. This okay. By the way, the points that cut, I mean the intersection points between the x-axis and the curve, they are called solutions or roots. So next time if you see roots, can you find the roots of something? Can you find the solutions of something? Generally, they talk about the intersection points between the x-axis and the curve. Okay, so basically you can see these 3 points, right? So you just read 1, 2, 3. Just read it to them.
Okay.
Solution means they want the x coordinate value.
Okay.
They don't want the y value because the y will be y equal to 0.
Yeah.
Okay, so if they ask for the solve, so you just x equal to what, x equal to what, x equal to what. So that's how you get C. Okay.
Okay.
So now, what if, write it again. Can you write x cubed minus 3x squared equal to -3? How do you do this question then?
This one.
Yeah, not -2, it's -3.
Okay. Yeah.
Yeah.
So. Okay. Plus 3. Okay. Oh, I think I know. Just take a.
I think we talked about this.
So why?
Correct. Yeah. So yes. So in a way, right? Because you need to remember, you have already drawn this, which is you have already drawn this out. Okay. So in a way, the approach, the subsequent questions, right? You need to somehow see how the question is related to this.
Okay.
Okay. So in a way, right, I ask you to do x cubed minus 3x squared. If I give you something else, like let's say I give you 3x plus 5, right? Let's say I give you this, and then somehow you need to use the graph to find this. So what you need to do is somehow you need to force this to be your plus 2.
Yeah.
So if you force this to be plus 2, over here is 3x. So in a way, right? So how do you get plus 5 that side? Plus 7. You understand?
Yeah.
You understand? So basically you just somehow get this the given question, and you force the left hand side to be the, because you always relate the question to the one given. So if you do some algebra manipulation, you will realize that the plus 2 here, you will move over to that side. That will be minus 2, right? And that's how you get your 3x plus 5, right?
Yeah.
So therefore, in fact, you have to draw what? You have to draw plus. You have to draw 3x plus 7.
Oh,
On that graph.
Yeah.
On that graph. So I just demo to you. Use the GeoGebra. So you need to do some math manipulation first. Then you will do 3x plus 7, right?
Yeah.
Okay. So over here, I think there is only one intersection point within the range. Yeah, just maybe this one. Okay. By the way, yeah. So this question is just I make it up. Okay. So I just want to let you know that this kind of question can be asked. Okay, and you should be ready for it. Okay, good. So next question. by drawing a tangent. So once again, find the gradient of the curve at 3, 2. So basically, you need to draw a tangent at x equal to 3. So we go to x equal to 3, right? X equal to 3, and then 2, right? So where is 3 and 2? 3 and 2 is here. 3 is here, right? 2 is here, right? So basically, you need to draw a tangent here.
Okay.
Okay?
So.
So you draw a tangent here, and then you do the same thing. Longer the better. Okay?
So the tangent, can it cut through or cannot? Or just
1 point.
Yeah, cut through at
1 point. 1 point only.
Okay.
So same thing. That point. Park your ruler here. Then just get it.
Can we like put it like, you know, the ruler, put it in between like that? Like the in between the graph.
Let me just get it here. So, okay, let me just resize it. So you insert your ruler at your. So let's assume this is my ruler, right? So you spot your 3, 2 first. 3, 2, 3, 2 is here, right? This point, right? Then you just park the ruler next to it to draw the tangent. Looks like the something like this. Okay, then you just draw this side.
Yeah.
Okay, so yeah, I just leave it to you. Okay.
Okay.
All right. So then after that you read your y1 minus y2, x1 minus x2. Then that will give you the gradient at that point. Make sense?
Okay.
So next. On the same axis, draw the line with a gradient 3 that passes through the point with coordinate. So gradient 3 that passes through the point with 0 and 1.
Oh, so basically they only give one of the coordinates.
They give you one of the coordinate, they give you the gradient. So
You need to find the other coordinate.
no, in a way, right, you need to get the line get the equation of this line out.
Oh, yeah.
Because only when you get y, let's say you get the equation of the line out, so let's say it's y equals to 2x plus 1, then only you can give yourself another table of value for this y equals to 2x plus 1, then you can plot the point and then sketch, right?
All this table of values, like, is there for this question? Like, there's about like 3 table of values you have to draw.
Yeah, sure.
So,
And by the way, hold on. Actually, some students, they are smart enough, they don't have to get so many points. I mean, I don't know, there are many ways to solve a question, right, by the way. So, you know why I keep telling you, in order to draw a line, a straight line or any curve, right, I prefer to give myself a table of value, then I will plot the point, then I will draw anything. Because this is the most fundamental way to draw anything. Some students, they go and memorize. Okay, so there is another way. They say what? On the same axis, draw the line with gradient 3 that passes through. I don't know whether you already have the gradient, you have a line of gradient 3 already or not. So what I'm trying to say is, let's say you draw this straight line out. Okay, let's say this is the this is the tangent, right? At so you need to label. So this is tangent at 3, 2, right? So let's say you go and figure out, oh, the gradient equals to 3. Let's say the gradient equals to 3. So for that question, it's going to be quite easy. You know that question gradient is going to 3, right? And then you must cut through 0 and 3, is it? Must cut through 0 and 1. Then must cut through 0 and 1, right? You know what you can do? Parallel lines. Oh, but of course, parallel you need two what? You need 2 rulers. Do you know what I'm talking about?
Yeah, kind of.
Okay, sometimes I understand, because this day I teach like in a school, then I just keep talking myself, and then the student just they get lost.
Yeah.
Because they don't, I mean, their brain can't process. So you park the ruler like this. When you have the gradient 3, right? So that means this line must be parallel to the other line. So you just park it. You don't you move against. That means you don't move this. You move it against like. Then you must cut the 0 and 1 versus 0 and here lor. Sorry I adjust it a bit because this must hit the above one. Okay. Then 0 and 1 is here. Yeah, here. This one. This is 0 and 1. So this one is parallel plus hit the 0 and 1. So you don't have to get the line of the. You don't have to get the equation of the line.
Okay.
Sorry. Understand?
Yep.
Okay. So this will be that question. How you answer the question fast. Then of course they will ask you to write down the equation of the line.
Right. So anyway.
Okay. So in a way, right, I expect you should use my method just now to get the parallel lines using two rulers. Using two rulers, so you move against, don't move this, move this against it, and make sure it cuts the 0 and 1. And then with this, then you can find out the equation of the line. And then it says write down the coordinate point where the line intersects the curve. So same thing, yeah, you see, cut the curve. So
just elongate the line.
Yeah, just lengthen it, alright, something like this. Okay, you should cut here, right?
Cut there.
Then the curve. Sorry, curve is here. This curve. This is another thing.
Line.
Yeah, different line. So they talk about curve. The curve is here, right?
Correct.
And of course, if you have this side, then of course you need to extend it. Yeah, extend it until you cut here also. Okay. So that's the two intersection point.
Okay.
Clear? Then what's the last one? This value of x are solutions of the equation of this. So find the value of this. Okay, good. So basically, you will get these 2 points, right? Right? They say these 2 points are the solutions to this. How do you find A and B?
Oh.
Yeah.
Okay. So just I think.
So always get do the question with relate it to the curve again. So I'm going to get on. So let's say somehow you get this is y equals to 3. Oh no, I can figure it out because y equals to 3x plus c, right? So they say this is 0.0, this is 0.1, right? This 1 equals to 0 plus c, so c equals to 1. Okay, good. Because this is 0 and 1, right? So then it has to be, so I sub in, then I get my c, right? So the c equals to 1.
Yep.
So therefore this is the equation of the curve. 1, right?
Yeah.
Okay, so they ask this what's the question? X cubed minus 3x squared. X cubed minus 3x squared plus ax plus b equals to 0. Let me double check. Yes. So in a way, right? So you start with the plus 2, right?
It's
Yeah,
11:15.
plus 2. And now, in a way, right? So this is your plus 2, and then okay, this is your original curve, which is this expression, right? And now you have cross this y equals to 3x plus 1 with the curve, right?
Yeah.
So in a way you need to use 3x plus 1 here. And somehow now what you need to do is bring the 3x plus 1 over.
Yeah.
So you will get this.
Minus 3x plus 1.
Good. So you just compare. A equals to minus 3.
X equals
B equals to 1. Okay? Okay? So always relate whatever question they ask subsequently, right? Just relate it to the graph. I mean the main expression or the equation.
Okay.
Alright? Okay, so yes, that's how you can do these two questions. And I let me be honest with you. If you can do these two questions, I think all the graph questions should not be a big
These
problem.
are quite easy.
Which one?
This, yeah.
These are quite easy. Oh,
Yeah, once
okay.
you understand it, yeah.
Okay, never mind. I can give you one more then to test your understanding. It's always easy if you're a passenger, you know.
Okay.
When you need to be the driver, then I don't know. Yeah. You need to be a driver. You need to look left and right and make sure that you don't bump into another car. You know, make sure that maybe someone just jump out of nowhere, and you need to avoid. As a passenger, it's always easy.
Of course.
Okay.
Okay.
Okay, good. So yes. Okay. This one, I look at some of your work, then I realize I don't know why you end up with that. Okay, so first thing first, this is your quadratic no, computing square.
No, yeah.
Okay, so I think you need to be super good with computing square. You know why?
Because so it's basic in
It's,
so
yeah, and it's used in equation of circle.
Yeah.
Okay, before you forget, I want to remind you, if you have 2x squared plus 4x minus 7, how do you complete square? You
divide
need
2.
Yeah, you need to divide 2 throughout first.
Yeah, x square must be 1.
Something like this, right?
Yeah.
Yeah, good. Then you do computing square for here. So before you do computing square, you need to get the coefficient of x squared to be 1. Okay? Anything other than 1, can't do computing square. Must somehow do some manipulation. Alright? Then once you get this, yeah, this is correct, but this is awful. Why? Because I don't know why you only show the half of the curve while you're supposed to show the other half.
Oh.
And you should show the full curve. If there's no range, or you call it what? This is range. This is domain restriction. There is no restriction here, so you need to show the full curve. Okay. So when it comes to this kind of curve, right? So once again, you don't use freehand. Use this. Okay. Use this. Okay. So yeah. So the point so you know that this is going to be a happy phase. So the minimum point is 2 and minus 11, right? Do you know how to read the minimum point?
Yeah.
From this?
Yeah.
Ask yourself, what is the minimum value you can get out of this?
Yeah, maybe it's a 0.
What is the minimum value you can get out of this? So this one must be positive, right?
Yeah.
This must be positive, so x has to be 2 lah.
Yeah.
So if x must be 2, then y equals to minus 11. That's how I read and then get my minimum point. So the minimum point should be 2 and minus 11, which is here. Okay? And then of course you need to label the I call these critical points. And then the one that cut, you also need to label.
And also the y.
And then of course this is called the roots. You also need to okay. Then you need to label y equals to x squared minus 4x minus 7. Can you see? Indicate clearly the coordinate of the turning point, which is this one. The point where the graph crosses the xy. Yeah, you see? You have to show all this. Alright? Then you need to make use of this. Alright? That's how you get. In fact, you don't need this.
Don't need?
Yeah, you don't need this for this. For this exercise. I mean, you can, but you are wasting your time.
Okay, then
how to draw?
How do you find the points to...
Okay, once you get this turning point, you know that this is going to be the line of symmetry, which is your x equal to 2, right? Then you know that your this graph is going to develop like this for the right hand side of the line of symmetry, and you know that this graph is going to develop like this for the left hand side.
Yeah.
Right?
Yep.
Then you need to get this point and this point out. So this 4 point actually you just need this 4 point, you can do a good sketch. So instead of just randomly give yourself this table.
Oh, you equated to y equals...
Correct. So basically you just y equals to 0, this one. Y equals to 0, this one will give you the roots. The roots means these 2 points. Just quickly use your calculator, quadratic function.
Yeah, then x equal to 0.
Then you x equal to 0, you will get minus 7.
I forgot all this stuff.
You see? Yep. So you see? Okay. This is I will say the tedious basic way to get any curve or graph. But for this question, you need to make use of the critical points. Yep, you have forgotten all the stuff. Okay? So I don't know whether this will come out or not, but if it ever comes out, then you will. Yeah.
I want to talk. So there are some changes for Emacs.
Yeah.
Since the student are really bad, they
Yeah.
can't do this. So
They can't do the what?
they can't do
Equation of circle.
7 point. There's a chapter.
Yeah, equation of circle or linear law.
Part of the equation of circle, I think.
Okay, never mind. Then we don't do that one.
No, equation of circle is Emacs. This is Emacs.
Okay. Okay.
So seven. Okay.
Mm.
So this one is 7.2, right?
Mm.
So it stopped here. Also,
So-
I never learned this one.
Okay, good. So that means you are telling me this is not tested.
This tested,
Which
but
is not tested.
this is not tested. See all the signs.
Okay, no, stop. Okay, sine rule is not tested.
And then after that.
Cosine rule.
This one is tested though.
Which one?
Sine, cosine of this angle. Like this.
Wow, a lot of things. Okay, I understand. Good. I know what. No way. Okay, good. So basically, yep, this one, yeah. So, hey, you have not do 6 and this. Actually, these are the thing you need to know.
Wait.
Given your understanding of that 7 point whatever. Okay, so that's why I give you these 2 questions. Okay.
Yeah.
Okay. So why I give you all the questions here is because you tell me graph is tested, trigo is tested, whatever is tested. I just try to put all the relevant questions to the relevant topics. Okay. So now let's look at trigo.
I think Emacs is easier than Emacs.
Oh no, because you never spend time on
Emacs.
So yeah, you deserve not to score then, because you don't spend time. Right? It makes sense, right? If you don't spend time on EMAth and you still score, life is so unfair, right? Am I right or not? Does it make sense? Okay, so for trigo, right? For trigo, I think certain thing you need to know is the Tokaso thing.
Yeah, I remember this. Tokaso.
Okay, so Tokaso only work for right angle triangle.
Yeah.
Okay, it only work for right angle triangle. Okay, that's how I represent it. Okay, so if you have this right angle triangle, and then if this is your angle, I use theta. Okay, if this is your angle theta, this will be your opposite. This will be your adjacent. The hypotenuse. By the way, the hypotenuse is always the longest one. Okay, so if this if you look at this right angle triangle, another theorem that comes to my mind is the Pythagoras Theorem. So which is adjacent, in this case adjacent square plus opposite square will give me the hypotenuse square. Yep, because it's a right angle triangle, right?
Yep.
Okay, so usually we just use the first letter lah, to make things easier. Yeah, A-O-H. Okay, so in a way, right, so if we just talk about this Tokaso using this example, you are going to get what? Tangent theta is you're going to get O over A. Right? This one, right? Then if you have the sine theta, so you are going to get O over H, right? Then if you have this cosine theta, so it's A over H. So basically this one refers to this trait. Okay, so you know life is not always so simple, right? Life is not always so simple, right? So what if they give you like this? So this will be 90 minus theta, right? Am I right? Yep, it's 90 minus theta, the other one, because this is 90 ma. This is theta, so the size of this angle is 90 minus theta.
I thought it must be 180 minus 90 minus theta.
Yeah, that will give you 90 minus
180
theta.
minus,
Okay, good. So what if they say, if they give you this 90 minus theta, so if you look at that angle now, so your O and A will switch, right? Yeah, change. Very good. Oh, never mind. I continue to use the same letter. Okay, so let's say if I have tangent that angle 90 minus theta. So in a way, for this case is so tangent is opposite, right? So then hold on, I need to use this color. Opposite. This is adjacent, right? So in a way, let me use another color. So it's tangent 90 minus theta is equal to O over A, right? I mean, look at the color. Then this is sine 90 minus theta is equal to O over H. So in this case, cosine 90 minus theta is equal to A over H, right? Okay. So in a way, right, what I'm trying to show you here is this. O over A in this case, the black one, is in a way, if I use is A over O, right? Right?
Yeah.
And then this OH is AH, right?
Yeah.
Then this one will be OH. Okay?
Yeah.
So can you see that cosine 90 degree minus 90 cosine bracket 90 minus theta is equal to OH. So that means it's sine theta. Let's test. So sine theta, so let's sine 30. Is it equal to cosine 60? Can you use your calculator?
Sine 30 equals cosine 60.
Is it?
Yep.
Yeah, okay. So what I'm trying to tell you here is yeah, so sometimes your teacher will ask you to memorize cosine bracket 90 degree minus theta is equal to sine theta. So like I say, if I ask you to memorize, you forget. Imagine, okay, you remember how much you have forgotten for the quadratic curve just in a short while. So I tend not to ask students to memorize. If they memorize, they forget very easily. So in a way, why I show you this one and this one, right, is to see if you can get it on the spot. And I think you can get it on the spot by just drawing this, and then you have no problem with this. You have no problem, so just get it on the spot. Okay?
Okay.
So you have any other questions on Tokasu?
No.
If
I
I
don't
move on?
have. Yep.
You don't have? Okay, good. So this is the okay, so I think your school never cover this part lah. Like the sine theta is actually equal to cosine bracket 90 minus theta.
Wait, is it chapter?
No, maybe they have covered, but it's okay. But you should get it on the spot.
Okay.
Okay? Or you can even use your calculator to test. Okay? Okay?
Okay.
Good. Next, for this, so basically you were saying, okay, let me just get the question from there, then we can talk about it. Get the question 6 out. Actually, I don't care whether they involve the whatever, because I think whether they involve the sine rule or not cosine rule, it actually doesn't matter because it's very easy to remember.
It's 11:30.
Alright, so if you look at this, I think you managed to get all the angles out. So can you help me out with this? What's the angle here? I want to get all the angles out if I can.
Okay. So ACD, okay, 180 minus 45 minus 40, 95.
Thanks. Okay. So in a way, this is not a right angle triangle. I cannot use Tokaso, right? And then now, they say AD, right? They ask you to find AD. AD is this one, right? Okay. So you know this one. Okay. So there is this. Okay. Where? Okay. You see, this is tested. That one is not tested. You know, I lose the continuity. I don't like that. Okay. So it's good that you just learn everything, right? So you learn, and by the way, when you learn everything, right, it's not so hard also. Remember, this side faces this angle. So this side faces this angle.
I think
Okay?
I know it.
So therefore, you can use the they call it sine rule lah, huh? Sine rule. Sine rule means you sine the 40, you over the side. Over the side, that side is this angle, opposite side is this. So face 55 is equal to this
Sine 95.
sine 95
Over the side.
over this opposite side of the 95 degree.
Yeah.
Okay, so this is 80. Okay, so this is sine rule. So that means the ratio remain the same. So same thing like if I sine the last angle 45 over this CD, yeah. But we don't need to find CD, right? Do I? Okay, so no need. So we just focus on this.
So what about the cosine?
Okay,
Cosine.
that one later.
Okay.
Okay, so you just get this right. So basically, if you give yourself the notes, right? You give yourself the note. So generally, what they call this side A, side B, side C. Oh no lah, let's use ABC better. Okay, so in a way, right? They call this A, they call this B, they call this C. Side A, side B, side C. So in a way, how do you remember sine rule? Sine angle A. This is angle A, right?
Because
Where's the opposite?
over B.
Over B, which is side B, is equal to sine angle. Which angle you want to pick first? B. So where's the opposite? Yes, correct. And then if you continue, so
Sine C over A.
angle C over A. Correct. You memorized already. Pretty easy, right? Okay, good. So once you get this, then I think you just get the value out from here. Then you get the AD. Yep, cross multiply. Okay. Yep, so you can get AD already easily. Can you help me out with what is AD?
Okay. Sine 40. Okay. Because sine 95 times 55. So 54.790.
Okay, just for our convenience, I don't want to.
No. But then that one need to divide by. Yeah.
No, I want AD. Okay.
Yeah.
Give me AD.
It is 85.09.
Okay, 85. Okay, 85. Okay, for our convenience. Okay, so that's how you get AD. So this is. Okay. So now, the area of triangle ACD. Where's ACD? So okay, so ACD. This triangle, right? Okay. Actually, there is a formula you can remember, but if you cannot remember, also never mind. Just get this out. I'm going to show you. Actually, that formula is derived from, it derived from somewhere, something.
Just
but
like
maybe your teacher never teach you, so you don't know that formula comes from somewhere. So this is 45, right? And then you have 85, and then you have the 55, right? So what is the how to find the area of a triangle? Half times base times height, right?
Yeah.
Right. So I think you have the base, which is 55. Oh, it depends which one you look at.
Yeah.
You can see 85 as the base. Okay, let's take 85 as the base. Right. So the height will be here, right? Right. So if this is the height, this is 90 degree, right? Can I ask you how do you find the height? Tokasu.
Oh.
This is the angle, 45.
Side.
This is the opposite, right?
So
this is the hypotenuse, right?
Yeah.
So sine 45 is equal to, in this case, is our height, because opposite,
Yeah.
right?
So is
Over 55, right? So therefore, the height is actually sine 45 times 55, right?
38.8.
什么 38.8. Yep, good. That's how you can get it. So in a way, right, if I want to see AC as the base, right? AC as the base. So the height will be, where's the base? Where's the height? Here, right?
Imaginary.
Something here, right? Okay. And by the way, this is also imaginary because It's not.
It's not everywhere.
It's not there. So this is 45 degree.
Mm-hmm.
This is your opposite, right?
Mm-hmm.
Can you use the adjacent or not?
But use hypotenuse.
Cannot use adjacent because your adjacent only 55 and 55 only reach here,
Yeah.
right? Yeah, just to let you know. So you can only use hypotenuse. Okay? Okay, so it's sine
sine 45
45
equals
opposite over 85, right?
85.
So in a way, opposite is 45 times 85. There is a degree here. There is no degree here. So to differentiate, this is the angle, that one is value. Okay, so you should end up with the same answer. Can you help me out? Oh no, I mean the area should be the same. Like, let's do it. What's this? Sine 45 degree times 85. So the opposite is
60.1.
60.1. Okay, we are going to test both out. So this one is half times base 55 times height, which is 60.1. Okay, good. What's this?
1652.
1652. What about this?
Right. 1649.
49. Okay, they are kind of slightly off because you know I have rounded a lot of things actually.
Yeah.
Okay, but this is the idea. So what I'm trying to tell you is don't round off in the intermediate step. If you round off in the intermediate step,
Can I get the actual answer?
you cannot get the more accurate answer. Yeah. Okay, so I have demonstrated to you how you can do both ways, right? Angle or BAC, where's angle BAC? BAC. Okay, good. This one involves the cosine rule.
That's right. Sine. Actually, you can delete everything.
Actually, I don't want to delete everything because I want to retain this sine rule.
Okay.
Okay, so cosine rule, right? Because later I'm going to tell you when you use sine rule, when you use cosine rule. This one.
Yeah.
Okay. So cosine rule is like the Pythagoras Theorem. Okay. So let me make use of this. Let me make use of this thing first, because my sine rule come from this thing, this triangle. Oh, by the way, sine rule and cosine rule, they work for all triangles. Tokaso only work for right angle triangle. Okay, so if I make use of this, let's say now I need to find the angle A. Okay, so angle A, question mark. Okay, let me use cosine rule. Of course, I can use sine rule, but use cosine rule. Okay, cosine rule is the opposite side is the B, right? To the this one, right? So it's
actually, is it like minus
B square equals to A square plus C square. Wow, I have forgotten already. Okay, I have forgotten. So I have not used it. Never mind, let me test myself. Cosine angle A. Can you help me check?
Yeah, let me.
Yep, please.
Is it?
By the way, I'm not sure if this should be given. I mean, there is a formula sheet, you know.
Yeah. They here I say it's given in the cover page.
Oh, okay, good. Can you see the cover page? Can you see the?
Oh, you want me to search online?
Yeah, just O level E-math formula sheet.
Is it email? Actually, isn't it the same?
No. Must be E-math. E-math. I want E-math. Yeah, this is the one. Yeah. Can you zoom in? Is cosine rule given? Yeah, you see here. Yeah, A square. Can you see A square equal to B square plus, it's minus. Okay, sorry. So minus, yeah, so minus 2AC in this case. Okay? In a way, so it's minus 2AC because 2AC is this one, right? So, yes. And let me highlight the most common mistake among students for this. Okay, so it's times times cosine the angle A. Okay, so just sub into it lah, right? So it's 110 square equals to A square is 55. This is 74 minus 2 A is 55. C is 74 cosine angle A, right? You know the most common mistake here? They go and do the minus first.
Oh.
I'm looking at you, okay? Okay. So never mind, help me out with the question, right? So 110 square. We do it step by step.
12,100.
12,100. 55 square.
3,025.
3,025. 74 square.
5,476.
Just read the digit.
5476.
Yeah, easier for me to digest. 2 times 55 times 74.
8140.
8140. So a lot of students, they go and do this first. Wrong, huh? Because there is a times, so that means what? That means this one is together. You can only do this part only. So can you help me out with this? Oh, never mind. In fact, I need to move these 2 over. So that means 12100 minus 3025 minus 5476 equal negative 8140 cosine. Yeah, good. Can you help me out with the left hand side?
3,599.
Okay, 3 digit.
3599. Oh, then you divide by 8
Divide by negative.
negative.
Okay, so cosine angle A is equal to 3599 over negative 8140. Yes. Can you give me the right hand side first?
Negative 0.0.
Negative?
Negative
Point
0.44.
0.44. Okay, good. So how do you get the angle A? Is angle A equals to you inverse, yeah. You inverse, then bracket negative 0.44. Of course, for our convenience, you don't. Yeah. Okay, good. 116. Okay, looks good. Yeah, looks good. Yeah. Okay. That's cosine rule. By the way, are you given sine rule and cosine rule during your upcoming term 3 test?
I don't think we learned cosine rule at all.
No, whether you learn it or not, are you given a formula sheet? I want to know.
Yeah.
Okay, good. Then like that, then you just remember. I mean, yeah. And by the way, you have 1 more week to digest sine rule and cosine rule. Okay.
So b square. So how you know what's b and a?
How I know what?
What's like the b and a?
You're talking about sine rule or cosine rule now?
Cosine. Sine rule.
Cosine, right?
Yeah.
Cosine, like I say, right? They want to find this angle, right? I look at the opposite side. So that means b square is the one on the alone. Okay? So b square is alone. The rest is other side.
Okay.
Yeah, that's how you fill up, lor. Understand?
Okay.
Yeah.
Okay.
Okay. So yeah, good. So the bearing of A. Do you know what's the meaning of bearing of A from B? So you go to. They say from B, right? From B, right? So you go to B first. Okay. From B means your this one must go to north. I assume this is north lah because they never tell north. That means north is always directly up lah. Then you just from B to bearing of A ma. So that means you go to A lah. Go to A lah. Where's your A?
There.
Here, right?
Yeah. Is it?
So that means until here lor. Right?
Not west.
Yeah. So basically you need to find out this angle. Okay?
Oh.
To find out this angle.
Bearing is
Yeah.
angle.
Yeah, bearing is angle, yes.
Okay.
Are you taught bearing?
Sec 1.
I don't know.
Geography.
Yeah, so basically you need to find out this angle, yeah. So to find out this angle, what you need to do?
Find out the
Find out this angle first. Then you also is okay. You can also see this as this. You also need to. This is 90. This is what just now is 116 degree, right? So then you can find out this already, right? So what is this?
180. Say 90 minus.
No. 360 minus the 3 of this.
36. 154.
154. And you can use the internal angle to find this. This is what? 180 minus the 150. Yeah.
26.
Then you use 360 minus the 26. That is the reflex.
Bearing.
Yep, the bearing.
334 degrees.
Yeah. Okay. So if
What's that?
so, let's say you have point C, point B. Let's say you want to find the bearing of B from C. From C, right? Go to C first. Draw a north. Okay?
Okay.
Right? In this case, if they never specify north is directly up. Okay? Sometimes they will say north is this. Then you have to use that. You understand me or not?
Yeah.
So the north is not always directly up. Sometimes they will specify. So you just draw directly north. Then go back to from C, right, to B. So basically it's from C to B. In a way, you can see this as from C north to B. That's how you read the statement here. So from C, right? So it's just north to B lah. So from C north to B, this one you need to find this angle. Understand? Now I want to test you.
So it's always like from.
So now I give you this C from B. Tell me how to do.
Draw the.
Okay, how do you convert this statement first? From B
From B
North.
north
to
to
C. Yeah, you need to somehow convert this to this, so that your mind can digest. I don't know why this is my way of thinking this statement. Okay, I need to convert it into this statement first. Then it's going to be easy. From B, so from B go to B lah. North, right? What you do?
Draw straight line up.
Draw straight up north.
Not specific.
Then to C, right?
Yep.
To C how? Where? From here, right?
Yeah.
This one. Okay? Understand? Understand like how do you read the bearing or something from something? So you need to convert the statement into this. Okay? Yep. So that's our first half.